Today we will discuss population inversion, pumping, active centers, active medium, types of laser. In the last lecture we have discussed basics of lasing action, what happened when the light or electromagnetic wave interact with particles, what is the meaning of absorption, then spontaneous absorption, then stimulated emission. We have discussed these things in the last lecture. This is the syllabus that we're supposed to learn. Today in this we will learn 4 and 3 level pumping scheme. And basics. So we will learn this. Until now you can see this. For condition of lasing action, the important thing is population inversion. Then we will discuss basics of what are accelerated, active medium, and types of laser. We have discussed this emission the last lecture. Electrons normally want to live in ground state, level 1, and whenever we give some energy, so due to excitation, it moves to higher energy state. We have shown here as a level 3. Now, this level is highly unstable, so they want to move to ground, either the ground state or the other states. In these materials, lasing action materials, we have some additional states. So the excited atoms don't move directly to the ground state, but first move to level 2. Those states are called metastable states. Metastable states means stability is basically stability is more than excited state, but less than ground state. Now they accumulate at the metastable state. From there, they move to ground state. But what is the condition when it can move? That is called population inversion. In the last turn, we have discussed various processes: absorption, emission, spontaneous emission, and stimulated emission. For lasing action, we have discussed these two conditions. Actually, for lasing action, stimulated emission is responsible. So, stimulated emission should be more if you want faithful lasing action. And so they have calculated that stimulated emission should be more than absorption and spontaneous. So finally, they have concluded these two conditions. And first condition is N2 must be greater than N1. N2 and N1 are the population of different states. So the condition is there should be more electron at excited level than at ground state. This is first condition. And the second condition is if you want to get lasing action, applied energy must be very high. For the small energy, it is not possible. The first condition, it looks a simple condition, but the condition is very typical. Normally, N1 is more populated than N2. Atom wants to live in ground state. But here the requirement is excited state or have more electron than ground. Achievement of first condition is called population inversion. Why with this termed as population inversion? Because this is not natural condition. Naturally, population of higher state is less than population of lower state. But in this case, we have reduced the situation. Normally, you can write the value of N1 and N2. N1 can be done as exponential of Similarly, you can also write down the value of N2 exponential of minus E2 over KT. E1 and E2 are the energy level, energy of the energy levels, and K is the Boltzmann constant, T is the temperature. But you want this. This can never be exist in thermal equilibrium. To achieve this population inversion, we want to push our system from a natural thermal system to non-equilibrium state. So this is a not natural process, and that is the reason even though Einstein suggested and thought first on 1920 about this, it was not possible to get the Lenzing action till 1960. The reason is, how can you create this population inversion? The discovery of metastable states played a very important role in this. Now we know that there are certain materials which have metastable states, which is close to excited state, and after excitation, the excited atom can live some time at these states. These states can be utilized as pumping inversion, population inversion condition. If you pump in such a way that the more electron move to excited state, but don't return to directly to ground, but first they move to the metastable state, then ground. So there is a possibility at some time that you may have more atom in the upper than the lower. However, if high energy configuration predominates, condition known as population inversion, the spontaneously emitted photons are more likely to simulate further emission, generating a cascade of photons. Heat alone doesn't produce population inversion. Some process selectively excite the atom and molecules, and this is done by eliminating the laser material with bright light. In this figure, on the left side figure, we have shown normal distribution. The ground state is highly populated, but as you move away from the ground state, it's less populated. But in the case of population inversion, the lower is highly populated, but they excite these to move to higher state, and from that is again less stable. So from there they move to third state, which is slightly lower than the second state, where it can live for a longer time. Population inversion in a state of system which deviate from thermal equilibrium. In thermal equilibrium, the population of lower always is always higher than other accept levels, and a positive net gain can never occur. Here it is giving the idea of popular optical pumping. We pump the system by sending photons. You can see here photons are there. Due to this move to higher energy state, and from there you may have now these photon move to lower state, and here you observe a condition of phasing action. This is what happened. For a material to give lasing action, some important points are: first thing is we use word active center. Those elements that directly involved in lasing action called active centers. So the material must have some active centers where lasing action can occur. For example, in ruby laser, basically ruby laser is a chromium doped Al2O3 alumina crystal. So in this ruby, chromium called active centers. They are always small in numbers but responsible for lasing action. The second important material thing is active medium, the medium in which active center lives and performs. Directly, these elements are doesn't involve in lasing action, but it supports active centers. So again, both are very useful, and the active medium is big in number. It surrounds the active centers, but both are useful. Even active center can't give lasing action without good active medium. Those materials in which both materials properties exist, properties of active center and properties of active medium, called lasing materials. Lasing materials are those materials in which lasing action can be obtained. Active center, active medium can be developed. Many lasing materials we know. For example, again I have discussed ruby crystal. In ruby crystal, we have ruby that can give lasing material. Lasing. Helium neon laser. A helium, we join helium and neon in a particular ratio, it gives lasing action. On the basis of energy levels, you can think about three types of laser: two level laser, three level laser, four level laser. In a practical sense, two level laser never exists. Two level laser, actually, lasing action takes place between two levels, and these two levels you must have one higher level and one lower level. So that high level is called upper level lasing level, and lower is called lower lasing level. If you have only two levels, then the minimum levels are ground state where the electron live or atom live. Then second minimum level is excited state where you can send your atom by giving some energy. Now between these two levels, the laser cannot exist because of the difficulty of challenge of population inversion. You cannot achieve population inversion between these ground state and excited state, because as you excite the atom from the ground state, it moved to the upper state, but the lifetime is very small. Within 10 to the minus 8 seconds, it can return back. So after some time, you will observe an equilibrium. The number of electron moving upward and number of electron moving downward will be same. So condition of population cannot be achieved. Now one more reason can be discussed, can be given on the basis of Heisenberg uncertainty principle. We know that the product of uncertainty in energy and uncertainty in time is always of the order of h. If somehow you want to increase the del t, the time interval between these two, so that the condition may achieve, then this will decrease the del E and decrease in such a way that these two levels are very close to each other, which is not possible. So we say the two level laser is never possible. Here I am giving you brief about 3 level 4 level. In 3 level laser we have one excited level and we use ground state as the second lower lasing level. This is possible, and ruby laser is the example of 3 level laser. We will discuss these things in detail in the next lecture. There is one more efficient option is 4 level laser. In the case of 4 level laser, upper lasing and lower lasing both are metastable states, and we don't use the ground state, even ground state for lasing action, because if we use ground state as we are discussing the 3 level, then continuous lasing is not possible. So that is the fourth option, 4 level laser, in which both are metastable states. Helium neon laser and CO2 laser are the example of 4 level laser. ND are also there. We will discuss these laser details in the next lecture. Thank you. We will discuss some examples of 3 level and 4 level in the next lecture.